Have you ever found yourself sifting through a massive collection of data only to feel overwhelmed by the sheer size of it? If that sounds familiar, you're in the right place. Today, we're diving into how to efficiently search within a large vector in C++. I totally get it. When you're dealing with large datasets, it can feel like searching for a needle in a haystack. You're not alone in this struggle. Many developers face similar challenges when trying to optimize their code for performance. Let's take a closer look at the specific question at hand. One user recently asked, how can I find a pair within a large vector of pairs where both members are contained in another vector? This is a common scenario, especially when the size of the vectors vary significantly. So what makes this problem tricky? The user has a vector of pairs, and they want to check if both elements of each pair exist in another vector. With the size difference and the need for efficiency, a simple loop might not cut it. Let's explore some smarter solutions. And stick around. At the end of this video, I'll share a powerful technique that can significantly speed up your searches, making your code more efficient. To efficiently find pairs in the vector pair where both members are in the vector, the user should first create a hash set from the vector. This allows for quick lookups. Next, the user should iterate through the vector pair. For each pair, they will check if both elements exist in the hash set created from the vector. If both elements of a pair are found in the hash set, the user can store or process that pair as needed. This approach significantly reduces the time complexity compared to a nested loop. Finally, since the contents of the vector will change after each iteration, the user should repeat the process by updating the hash set with the new vector contents before each check. Fun fact, did you know that the first computer algorithms were created in the 1800s? Ada Lovelace, often considered the first computer programmer, wrote an algorithm for Charles Babbage's early mechanical general-purpose computer. Now, let's look at the answers provided by other users. An alternative approach suggested by a user is to create an unordered set from the vector. This allows for efficient searching, as looking up elements in an unordered set is approximately O1. Let's take a look at an answer from another user. An alternative approach suggested by a user involves using a map for efficient searching. First, they recommend inserting all elements from the vector into a map. Then, for each pair in the vector of pairs, you can quickly check if both elements exist in the map. Additionally, the user suggests using unordered map for even faster operations, enhancing the performance of your search. That's the end of that answer. Let's see another perspective. An alternative approach suggested by a user involves using an unordered set for efficient searching. First, you create an unordered set from the elements in your vector. Then, for each pair in your vector of pairs, you check if both elements exist in that set. This method allows you to perform the search in average linear time, making it much more efficient. That's it for that answer. Let's take a look at another one. An alternative approach suggests using a std unordered multimap instead of a vector for vec pair. This allows for faster lookups. If the order of elements isn't important, you can construct a constant unordered multimap from the pairs. This way, if a key isn't found in vec, you can skip checking all its associated values, improving efficiency. Additionally, you can create an unordered set from vec for quick membership tests. This allows you to efficiently check if both elements of each pair exist in vec. The user provides 2 code examples demonstrating both methods. That wraps up that answer. Let's move on to another one. One alternative approach suggests checking how much smaller vec is compared to vec pair. If vec size squared is still much smaller than vec pair, consider using an unordered set for vec pair. This allows you to efficiently search for every possible pair generated from vec. Additionally, if sorting is an option, create sorted copies of both containers. Then use 2 pointers to traverse both lists looking for matches. This method maintains a time complexity of O size of vec pair, but reduces constant factors significantly. Here's the pro tip I promised. Always consider using data structures like hash sets for faster lookups. This small change can make a huge difference in your code's performance. And there you have it. You now have a more efficient way to search within large vectors in C++. Remember, optimizing your code can save you time and frustration. If you found this video helpful, please subscribe for more tips and tricks.